Hello my students. Today our class is classification of lakes. In the previous class, we have learned classification of lakes on the basis of their origin. In today's class, we will learn how to classify lakes on the basis of their thermal profiling. So in this class, what we will know? We will know how to classify lakes based on temperature profiles of water. We will be able to understand the behavior of temperature in different types of lakes. We will be able to differentiate between two types of lakes based on temperature profiles. If we classify lakes on the basis of the water zones, we will find three basic zones. One is littoral zones, pelagic zones, and profoundal zones. We can also classify the water in a lake on the basis of the penetration of light into the water, that is light aphotic zones, which means the light reaches this level of this zone of water, and aphotic zone where light cannot reach. Here you can see, just by the side of this, I have shown one more classification, which is based on temperature, where the top layer is called apolemnion, then another is called thermocline, and the bottom one is called hypolemnion. So we have three different types of classification based on water zones. First one is the littoral zone, based on the depth or distance of the water body from the shore area or from the bank. And then littoral zone, the part where the maximum water body resides. And also profoundal zone, which is the deep part of the water body, or you can say the aphotic area of the water body. Then you can have two basic zones, which are photic and aphotic zones, that is where the light can penetrate, and in another zone, aphotic zone, light cannot penetrate. The classification which we are going to discuss is based on temperature. So temperature has three zones. One is apolemnion, two is thermocline, and three is the hypolemnion. So these three zones are the basic zones which we are going to discuss, on the basis of which the lakes have a major way of classification on the basis of the density, or according to the density due to different temperature. Thermal classification of a lake can be said when the lake water body is divided into distinct layers of density due to different temperature. So this is what the classification of lake based on thermal character. Here you can see we have classified the lake water into four very distinct zones. Apolemnion, that already we have come to know what it is, the top surface water of the lake. Then metalemnion is the middle water layer. Then thermocline, a zone of water where temperature changes very rapidly. And the hypolemnion, which is the bottom part of the lake water body. In terms of temperature, we can have a graph like this. This is the temperature you can see, and this is the depth of the lake. So here the first temperature of this area of the body or water body, see this area of the water body is around 20 to 25 degrees Celsius. This is apolemnion. Then it suddenly changes. So this is metalemnion. And then it comes to hypolemnion. The water is almost fixed, that is 5 degrees Celsius, and it is the hypolemnion layer of the water. So here somewhere in the metalimnion you'll find the thermocline, where the temperature changes very rapidly, and that is the area which which gives that there is a difference between the hypolimnion and rest of the layers of the lake. Epilimnion, if we go in detail, it is the warmer and typically has a higher pH and dissolved oxygen. This area has warmer temperature and typically high pH as well as dissolved oxygen. So why this dissolved oxygen? High dissolved oxygen, because the water surface is always mixed with the wind of the surface. So it gets, the oxygen gets saturated to the water of the lake, to surface water of the lake. Then it is free to exchange dissolved gases like oxygen and carbon dioxide with the atmospheric concentration. That is the another reason why it has high dissolved oxygen in it. And since it has a good volume of dissolved oxygen, and the water has sufficient light, you will find most of the phytoplankton in this area. These require photosynthesis and respiration, so this group of organisms are very high in the epilimnion area. Then comes metalimnion. As I told you, it is the slowly or gradually decreasing temperature area, metalimnion. And there somewhere you'll find a thermocline, which is the zone of changing water from one stage of temperature to the another stage of temperature. So temperature changes rapidly with depth than it does in the layer above or below. So this is called metalimnion. And there in the metalimnion you will find thermoclines. Thermoclines may be a semi-permanent feature of the body of water in which they occur, or they may form temporarily in response to phenomena such as the radiative heating, cooling of surface water during the day or night. So thermocline is, in a very simple way, is a very rapidly changing water body in terms of temperature. So metalimnion itself is a thermocline, but metalimnion means it is a depth, or you can say it has a definite definition, limits. This is the starting of thermocline, and this is the ending of the thermocline, and in between this area is the metalimnion. Then factors that affect the depth and thickness of a thermocline includes seasonal weather variations, latitude, and local environmental conditions such as tides and currents. So now the last one is a hypolimnion. Being at depth, it is isolated from surface wind mixing during summer and usually receives insufficient irradiation, or you can say light, for photosynthesis to occur. Obviously, during summer or any period when water is full in the lake, this hypolimnion hardly receives any light, and there is no wind mixing because it is the interior at the depth of the water body of the lake. So this is a very in case of lakes which are very deep, it is the aphotic zone where light cannot reach. So typically the hypolimnion is the coldest layer of a lake in summer and the warmest layer during winter. Coldest layer of a lake in summer, it means during summer the epilimnion is hot, or you can say warmer, but during winter this epilimnion becomes very cold, sometimes covered with ice, but the lower layers are having temperature more than 0 degrees Celsius. So during that time winter, this is the warmest layer. In deep and temperate lakes, the bottommost waters of the hypolimnion are typically close to 4 degrees Celsius throughout the year. So it is the highly dense water during that period. Another very commonly used term is lake overturn. Lake overturn is a circulation which recharges oxygen and nutrients through the basin. What does it mean? It has a capacity of recharging. Recharging means the reusing, or you can say it is refeeding the oxygen and nutrients to the lake. So where you can see during summer there are the whatever situation of the lake may be different in the winter. So whatever the situation in terms of oxygen and nutrients during summer may not be same during winter. Here you can see during summer it is very beautifully structured layers. There are three layers are there, and as we have discussed in the previous slides, it is very clear that during this in this stage where the layers are very distinct, the different characters depending on the light penetration, oxygen, carbon dioxide are different across these layers. So the nutrients and oxygen levels are different in these different layers during summer. But when it comes winter, it is covered with ice, and the lower layer is having 4 degrees Celsius water. This water is having 4 degrees Celsius. Obviously, this situation will not favor the nutrients and oxygen which was available during summer. So there is a difference of oxygen and nutrients during winter lake than the summer lake. So when again this summer comes, it reverts, it returns to the summer situations. So overall there is a loss and gain, charging and recharging of oxygen and nutrients in the basin. This is called lake overturn in limnology. So annual lake cycling is there. What is the importance of lake overturn? Because there are annual cycling in lakes. At least 4 distinct annual cyclings are clear, known to all limnologists. In the first case, you can see this is the summer case where stratified lakes are there, the winds are there, so it is having a different overturn. Then there is a mixing of water where these layers have gone, layers are not there during the fall, and then the overturn is different. Then it comes to the winter where this mixing is lost and there is a slight layer, you can see ice is there and below 4 degrees Celsius. So this situation has a different lake overturn. Then it comes spring, again the mixing takes place, so the situation returns to fall like situations. So this is what the lake overturn again changes. So every time the lake's health is defined, we can define in terms of this lake overturn. So let us have a look on the different situation of a lake across different seasons. Say for example winter. During winter, you can see this is a picture of the lake during winter. Here on the surface the temperature is 0 degrees Celsius. Here you can see during winter water temperature below the ice is 0 degrees Celsius. So this creates a density inversion. 0 degree water is lighter because, as you know, that the dense water comes at 4 degrees Celsius. So when it becomes ice, it floats on the water. So here this 0 degrees Celsius of water, which is actually ice, it floats on the water, and rest of the water becomes 4 degrees Celsius, which is dense water, very dense water. So the hypolimnion, which is at the bottom, at the below part of this ice cover, it becomes anoxic, and nutrients are mobilized in the sediments. Because these nutrients cannot float up, or the organisms are there, it fails to recycle. Finally it settles in the sediment of the lake, in the bottom of the lake, and build up the deep water layers. So this is what the fate of the lakes during winter. Then when the spring comes, the ice which covered the lake on the surface, it gets melted. So the strong winds, lowered surface temperature, and the absence of a thermal stratification allow complete mixing of entire water body. It means the ice cover is not there, the dense water is not there, the whole situation of the lake is now different, and there is no stratification because the ice melted and it gets mixed with the water below its level. So this is there is a total mixture of water. Slowly it becomes the mixture of nutrients and oxygen. Then mixing brings up nutrients from the lake bottom. As a result, it becomes a nutrient rich or nutritionally balanced lake. Anaerobic condition in lower depths are changed to aerobic ones, obviously. So this is what the fate of the lake during the spring. Then comes summer. Summer is, you can say, the most favorable, and the categories or different criteria features are very much visible in lake biology or limnology, because when summer comes, the increased solar radiation heats up the uppermost layer, which lowers water density and viscosity. Then the lake becomes very well stratified. Here we have seen, already have discussed in the previous slides, that when we classify lakes or stratify the layers of the water body in a lake, we can classify them into three different very distinct zones. That one is the apolymian, then thermocline, and hypolymian. So there, in this classification is possible only when it is summer. During summer, the top layer is apolymian, which receives sufficient sunlight, and it is a photic zone, rich in nutrients and rich in organisms to circulate the nutrients. Then thermocline is a zone which receives less light, but still there is a change in temperature, very rapid change in temperature here. As the depth increases, the temperature goes down rapidly. Then it comes the hypolymian, where there is no light and rich in sediment. Sediments are deposited here, and there are some organisms which are not planktonic organisms. Obviously, these are some nectan or some other aquatic organisms. So this is how the lake during the summer. Then fall. The fall, where winds, colder surface water, and the absence of thermal stratification, it allows mixing of the lake. Here you can see there is no surface, there is no wind, and the water is a bit colder, that is just above 4 degrees Celsius. So this allows a very homogeneous mixing of lake. In high mountain lakes, which are normally not deep, mixing can affect the entire water column, because it can mix the water, nutrients and oxygens throughout the lake water body in a very homogeneous way. So this is but in case of deep lake, the deeper water may not be enriched with such situation. But shallow lakes, because the water surface is very shallow, there you can find a well mixing of these characters. So the mixing brings back aerobic conditions and distributes sediments borne nutrients in the entire water column. Now these situations can give another classification of lake. And these two classifications, basically we have more classifications, but at this point, for this slide, I want to highlight two classifications. One is holomictic marine lake, and second is meromictic marine lake. This is holomictic, this is meromictic. What is holomictic? Holomictic lakes have uniform density and temperature regardless of depth in a particular period of year. So in this lake, at least for 1 year or a period of year, if the water has fixed column, means there is no layers and it is having a fixed column, this is called holomictic lake. Holo means homogeneous, making mixture. Here all the water and all other components are mixed very homogeneously. Meromictic means the mixing is not very homogeneous, but it is considerable. So there you can find a meromictic lakes, the layers. You can find the layers where the water do not intermix. This is the upper layer or this is the lower layer. The water do not mix for the meromictic marine lakes. Then if we talk about holomictic, we can have three more classifications for holomictic. One is monomictic. Monomictic means the layer is only one throughout the year. The layer is only one in that lake, and the mixing is also uniform within that layer. Another is dimictic. Dimictic means there are two layers, or mixing takes place in two ways. First, you can see this is one way during summer where the whole water becomes stratified and water mixes here, at least for two layers. Then you can come to next season, and here autumn, during autumn you can find the mixing of water takes place through the wind, circulation of the wind. Similar situation you'll find here, and then you'll find the two layers again. A layer at the top which is ice, and a layer at the bottom which is water at 4 degrees Celsius. So this is how called dimictic lake. They have two different forms. The two layers, one is top layer, one is bottom layer, and one is surface very shallow layer, one is bottom layer. And at the same time, throughout the year you can find these layers appears, and they are also there's intermixing. Then in case of polymictic lake, you'll find that there are some fixed zones, and above that the water mixes. This is what is called the polymictic lake. Here this is the, you can say, monomictic lake, but in case of monomictic lake, one layer is there where the water mixes up. But polymictic lake, the water layer one layer of water may be fixed, and the rest of the layer are mixing up with each other. So this is called polymictic lake. So here you can see the cold monomictic lake, the winter have very less classification and summer has good mixing up. Similarly, during warm monomictic, in case of warm monomictic lake, the winter has good mixing up and summer has very light classification. These situations can be expressed or explained here in this graph. There you can see this is a classification during summer, and in fall you can find all are mixed up very well. Then winter you will find there is a reverse stratification. The top is 0 degree and bottom is 4 degrees Celsius. So it is a different stratification. Then spring again it comes very flat, means the mixing is very homogeneous and well. So this is for the polymictic lake, where you will find the classifications or stratifications are uniform throughout the year. Although there is a mixing up of water for a short time period, but still during summer the stratification is very clean. There it comes for meromictic lakes. As you know, the typical meromictic lake has three very distinct layers. One is epilimnion, then metalimnion, then hypolimnion. So here you can see in case of metalimnion, this is thermal stratification, epilimnion, thermocline, and hypolimnion. That I told you, that thermocline is a rapidly changing area in terms of temperature, and this area is sometimes covered with metalimnion, but metalimnion is a little bit wider concept, and thermocline means every layer within metalimnion also gets changes in terms of temperature. So this is called thermocline. Here you can see that in this case the epilimnion is there, thermocline is there, hypolimnion is there, and chemolimnion is also there. So there, in case of chemolimnion, you can say the zone that mixes completely at least once a year. So this area, whole area, is mixolimnion. Mixolimnion means this zone of area that mixes completely at least once a year, and this area, this black area, it cannot mix. It never mixes. So it is monomolimnion. So mixolimnion means the zones, different zones. You can see apolimnion, thermocline, hypolimnion, and chemocline. All they can mixed up at least for 1 year. Then meromictic lag. In case of meromictic lag, this may happen at different forms. This mixolimnion may, you can see this is the area, and sometimes you may find chemolimnion is not mixing up the other rest of the layers, but still this is a mixolimnion. And there is a part which is totally not changing and even not mixing with rest of the leg. It is called monomolimnion. So the non-mixing bottom layer, that is monomolimnion, that I told you, is this part in this discussion, in this figure. So the non-mixing bottom layer, which is known as monomolimnion, is here in this meromictic leg, and the rest of these layers are well mixed up, or they can mix up very well with different assignments. So the non-mixing bottom layer is the monomolimnion. This is the blackened part, is the monomolimnion, and it is different from the mixolimnion, because in mixolimnion these are stratified and monomolimnion is not stratified. In some cases, the legs are also said as amectic legs. Amectic lag means they have the water whose surface is covered with ice throughout the year, which prevents the mixing of waters beneath. So it is totally fixed with ice throughout the year. Never in summer, never in fall, it changes. So that is why this is called a fixed lag or amectic lag. There, in case of amectic lag, you'll find the top body is covered with ice. It means here the temperature is 0. Then if you go down, you'll find the immediate layer of water is having a temperature little high than 0 degrees Celsius, but not as like as the 4 degrees Celsius. It is possible the 4 degrees Celsius is seen only when the water depth increases. So once one goes to deep of the water, in case of amectic lag, he or she will find 4 degrees Celsius water, which is very much dense at the bottom part of the particular lake. So this is, but at the top it will find ice. So this is the graph how it is shown, the 0 degree, then some part it got the turn bend to have that layers or the temperatures, just in case of amectic lag. So what we have learned in this class? We have learned that lakes are classified into 3 types, namely holomictic, meromictic, amectic, based on temperature profile. The holomictic lakes are further classified as monomictic, dimictic, polymictic, based on their thermal stratifications. The temperature profiles of each type of lake changes, and accordingly stratification appears, and those apolimnion, hypolimnion layers are very clear in case of summer, and rest of the part of the season they vary. Sometimes they mix up, sometimes they isolated or layered in the temperature profiles of each type of lake changes, and accordingly stratification appears, and this change is dependent on, or it is according to the different seasonal conditions of the area or the location where the lake is situated. So that is why when the summer it is very typically stratified for 3 layers, apolimnion, hypolimnion, etc. 3 layers. But during winter or fall, these 3 layers gone, and it is replaced with some other situations either the reverse situations, that means the the temperature is 0 at the top and the bottom area is 4 degrees Celsius or more. So this situation appears, and according to this, the stratification of lakes are classified. Thank you very much.